Okay, we're gonna begin by reviewing how to graph exponential functions. Now, do you remember, and I apologize, these t-shirts are not what I wanted to put on here, but we're gonna work with them. I'm gonna have you cross this out. Can you give me the parent function? This is y equals 2 to the x power plus 3. What's the parent function?
2 to the x.
2 to the x power, very good. Give me, I want 4 points. What numbers will you plug in for x?
-1, 0, 1, 2.
And what would be the, turn this into y like that? Do that. What would be your 4 y values?
1/2.
1/2, 1, 2, and 4. Okay? Now can you tell me what would be the transformation here? I'm just going to do x and y. What would you do to this table of values?
You'd add 3 to the y's.
You would add, this is a shift 3 units up, 3 up, which means you take your y values and you're going to add 3 to them. So what would happen to the x values? They stay the same. And what happens to your y values? You're going to add 3 to them. If you added 3 1/2, you get 3 1/2. Add 3. Make sure this is kind of confusing. You're adding 3 to this. Add 3 to this, you get 4. Add 3, you get 5. Add 3, you get 7. So these are the ordered pairs that you will sketch. You're going to plot. Okay? So what is this? It's -1 up 3 1/2, 0, 4, 1, 5, and 2, 7. It's a smooth curve like this. And see if you remember what the domain and the range are for this.
Range.
What is the domain?
Domain is all real numbers.
Domain is all real numbers. And what's your range?
Y is greater than 3.
Y is greater than 3, because what you have here is this asymptote. It's getting closer and closer to the line y equals 3, but it's not going to cross it. What's different about number 4? So what would you do and cross this out, write y, and then x and y. Let's do that. That's easier for you. So -1, 0, 1, and 2. You've got 1/2, 1, 2, and 4. Now what do you do for this problem? You're going to take your what values and do what to them?
-3 to the x.
Take your x's and subtract 3. X minus 3. So what is -1 minus 3? -4, -3, -2, -1. What do you do to your y values?
Keep them the same.
Keep them the same. So you would plot these points right here. Over 4, up 1/2, 1, 2, 3, 4, up 1/2. Over 3, up 1. Over 2, up 2. And over 1, up 4. And can you tell me the domain and the range?
All real numbers and
All
y is
real
greater
numbers.
than 0.
And what's your range?
Y is greater than 0.
Y is greater than 0.
Is the domain always going to be all real numbers?
For exponential ones, yes. For exponential one, the domain's going to be all real numbers. And your range, is anyone seeing where the range gets affected when you what? Can anyone say something? Look at that one. It was 3 units up. But this one wasn't up. It was right. So what number is going to affect that range? Is that D? Yeah, it's the good comment, good answer. It's this D value. So if I gave you 2 to the x power minus 4, this is going to move your graph 4 units down, so your range is going to be y is greater than -4. It's this big, the D value, that's going to change your range. Now, if you can do these, you can do what we're about to do. We're going to do logs. How do you graph logs?
I don't know.
Okay, I want you to look at number 2. Look at number 2. Everybody on number 2. Front page. Can you for me right now graph y equals 3 to the x power? Yes, you can. Give me 4 good points, quickly. -1, 0, 1, 2. You get a third, 1, 3, and 9. Graph those points for me. Over 1, up a third. 0, 1, 1, 3, and 2, 9. Let's see what this looks like. Now, can you tell me the domain in the range of this? The domain is
All real numbers.
all real numbers, and what's the range? Y is greater than 0. Okay, now, if I ask you to graph this problem, yesterday I taught you how to rewrite this. How do you rewrite this in exponential form? What would it, see if you remember. 3, good. 3 to the what power? Y is equal to x. So now, when I put numbers in here, I'm going to want to put them in for y. Because if I put them in for x, you won't be able to solve. So I'm going to do -1, 0, 1, and 2. And what are you going to get? You're going to get for x, you're going to get 1/3. When you put a 0 here, you're going to get 1. When you put a 1, you're going to get a 3, and you're going to get a 9.
So it just flips it.
So what do you notice about these points? Brett just said it.
They get flipped.
What's that fancy word?
Reflectors.
Not reciprocal, but
Reflectors.
starts with an I. These are inverses. Inverses is when you switch your x and your y around. And also, look at the equation. This one is y equals 3 to the x. This is 3 to the y equals x. These two are inverses of each other. So how do you graph? Let's check this graph out. Over a third, down 1. 1, 0. 3, 1. And 9, 2. Check this out. Each of these points is the inverse. This thing is a reflection over the line y equals x. Now, what do you think the domain and the range are? Well, if all your points are flipped, what do you think is going to flip also?
The domain and range.
The domain and the range, good. So for this one, the domain now is going to be x is greater than 0. In your range now for these ones will be all real numbers. So Alexa, you asked the question, are they always going to be, the domain going to be all real numbers? For the exponential one, the domain will always be all real numbers, and for the log ones, the range will always be all real numbers. Okay? All right. Now go back up to number 1. We're going backwards. How would you graph this one? What's the base on this one? 2. So this problem is 2 to the y power is x. So what's different about this is the base. So when you do -1, 0, 1, and 2, you're plugging them in for y, and you're going to get 1/2, 1, 2, and 4. So if I were to graph this over 1, half, down 1, over 1, 0, over 2, up 1, and over 4, up 2. And that's what this looks like. And again, your domain is going to be x is greater than 0, and your range is all real numbers. So how do you think are you understanding this so far? Okay. Now, right here is just all what we just talked about. They're inverses of each other. It's a reflection on line y equals x. And we did all this, the domain and the range. So now let's get into some transformation ones. Now, I'm gonna give you this problem before we do the next example. Okay, check this out. And check this one out. If I asked you to do this one, what would you do? You would give me the parent, what is the parent function? Y equals 2 to the x power. You would give me a table of values, and you would do -1, 0, 1, 2, 1/2, 1, 2, and 4. How would you graph this? What would be the first thing you do? That's the first thing. You're gonna add 3 to your x values, right? This is a shift 3 units right. Then, so you would add 3 to your x values. Then what would you do? Multiply your y values by 2, because it's a vertical stretch by 2. And then what would you do? Add 4 to your y values. Guess what you're gonna do here? Same thing. Same thing. You're gonna add 3 to your x values, you're gonna multiply your y values by 2, and you're gonna add 4 to your y values. That's it. But to what numbers are you doing these operations to? Well, you gotta know what the mama function is. This is what the parent function is, that's it. So where do we start? We start with 2 to the y power is x. So when you make your table, instead, this is where you have to kind of do it backwards. You're gonna do -1, 0, you're gonna put numbers in for y. You're used to putting numbers in for x, you do it for y. And you do 1/2, 1, 2, and 4. So if I ask, this is the worst case scenario, how would you graph this one? You would take your x values, these x values, and you would add 3 to them. Then you would take your y values and you multiply them by 2, and then you'd add 4 to those y values. You think you got this? Now, are they gonna make you do this all 3 operations for each problem? Like I said, no, that's the worst case scenario. So like for this one, this is your first example. We're gonna take baby steps here. Now, I don't like these T-charts, so cross this out, do x and y, and then do x and y like that. I think it's better. I apologize. I looked at it fast and thought, oh, it'll be fine. I'm not liking it. So, what's the parent function here? 2 to the y power is x. So we're going to plug in -1, 0, 1, and 2. I'm good with 4 points. And tell me what your x values are. You're going to get good at this.
2.5.
Yep. So tell me what's happening to this graph. It's shifted what? Is it up 3 units? Is it down 3 units? Is it left 3 units, or is it right for you? It's left 3. It's left 3. So how do you do a left 3? What do you do?
Subtract 3.
You take your x values and you're gonna subtract 3. What do you do to your y's? Keep them the same. So give me your 4 new x values if you subtracted 3. And keep these the same. So these are your points that you'll graph right here. Graph these. What does it look like? Over 2, down 1, 2.5, down 1. Over 2, 0. Over 1, up 1. And over 1, up 2. Now, can you tell me the domain and the range of this? What did we say the range is always going to be on these?
All real numbers.
All real numbers. But we shifted this 2 units left.
3 units.
Or, I'm sorry, 3 units left. Does anyone know what the domain is going to be now? I'm going to give you a hint. Drawing an asymptote here.
X is greater than -3.
X is greater than -3. Do you know where that shows up at here? Because Nick said it's the D value. It's not the D value in this case. It's the B value. It's this right here. What's inside the parentheses. That's gonna change your domain. So it's gonna be x is greater than -3. So you could shift something up or down and it's not gonna change your domain. Only that first hit right there, that's gonna change it. All right, now, number 6. If I told you the 3 can be switched somewhere else, where would you put it? At the very end. This 3 is really the D value. So this problem is really, it's really the log of x base 2 and then plus 3. I'm gonna tell you, if it's a shift left or right, it will be in parentheses. It will be in parentheses if it's a shift left or right. This is gonna be up 3 units. So how would we do this one now? So cross out the word work, do your x and your y. So for this one, what you're gonna do is, again, take your parent function, 2 to the y is x, which is -1, 0, 1, 2. And now what do you do to your table of values? Something gets,
Subtract or add 3 to the x's.
you're gonna add 3 to what?
The Y's.
Add 3 to the y's. So if we add 3 to these y values, what do you get? What do we do with our x's? Keep them the same. So we are shifting our graph 3 units up. It's not gonna change your domain and your range of your parent function. Only when it shifts it left and right does it. So over a half up 2, over 1 up 3, over 2 up 4, and over 4 up 5. And this is what this thing looks like. So for this one, your domain is gonna be x is greater than 0, and your range is gonna be all real numbers. And number 7 is fancy. We got 2 things we're gonna do here. Anyone think they know?
You're gonna move that 4 over to the other.
You're gonna, I would take that 4 and move it out here. So it's really 2 to the y power is equal to x. That's your parent function. Okay. So Nick, what is our first operation gonna be?
To subtract it.
You're gonna take your x values and subtract 2. Can you subtract 2 quickly for me? Subtract 2, what do you get? Subtract 2, subtract 2, subtract 2. And then what did you say you're gonna do? This is your D value, you're gonna do what? You're gonna subtract 4, y minus 4. So subtract 4 here, you get -5, -4, -3, and -2. These are your points you're gonna graph. Over 1.5, down 5, 1, 2, 3, 4, 5. Over 1, down 4. Over 0, down 3. And over 2, down 2. Here's your graph. Do you think you know what the domain is? Look here, that's gonna help you. Your domain is gonna be x is greater than what? -2, and your range is gonna be all real numbers. So look right here, make sure that your graph does not cross that line x equals -2.
And then, just notice on number 6 too, I noticed some have points or are on that y-axis. Should never touch it.
What's that? Should never touch
For
it.
number 6, they should never touch the y-axis.
Yep. Okay, next. This is your homework, 7-3.